Hi. Today we're going to talk about something practical for a change. We've been doing a lot of theoretical stuff and trying to get our feet on the ground. So we're going to use one of the nifty things about trigonometry. Here we're going to solve some triangles, but these triangles don't necessarily have to be right triangles. We're going to solve them by two techniques. 7.1, we're going to use the law of sines. And then in 7.3, we're going to use the law of cosines. So the law of sines is a nifty way to um, find the sides and the angles of a triangle. If we're not, if it's a right angle, or even if it's not a right angle, we can use this. The only thing we have to know is if we have two angles and one side, then we can solve what we call an obtuse triangle. So we have to have two angles and one side, and we can use the law of sines for it. So let me show what the law of sines is. Now, when we have a triangle, okay, and let's say this is side A, then opposite of that's, this is angle A, excuse me. This is angle A. Opposite angle A is side A. This is angle, it could be any one we can call them because it's not necessarily a right angle. Let's call this angle B. Opposite angle B is side B. And notice on angles we use capital letters, on sides we use lowercase. Of course, then this would be angle C, and this would be side C. So if we have two angles, say angle A and B, and we have a side, hopefully not C, but if we even had side C, we could solve for it. And it's all done basically by proportion. Um, A is the sine of A, angle A, as B is the sine of angle B. We could set it up that way, or we could say A is the sine of A as little side C is to angle, the sine of angle C. Or little side B is to sine of B as C is the sine of C. So A is the sine of A. We don't have to have all three. We just need two. We could have A to sine A and B to sine B, or we could have B to sine B equals C to sine C, or we could have A sine A, C to sine C. We usually determine by which angles we know and which sides we know. So let's try it. Let's see if we can do one of these fantastic problems. Okay, I'm going to draw a little triangle here. And let's see, maybe it looks sort of like this. And this is, we're going to label it, this is side A. This is in your book on page 292. This is angle A. This is angle B, angle C. Side A, side B, side C. And on this particular one, they said, we're given this triangle A, B, C. A is 32 degrees. That would be our angle right here. B is 81.8 degrees. And small a is 42.9 centimeters. So we know that information is given to us. It says on this drawing, start by drawing the things to scale and the given parts and known. And what do we want to find on this? We want to find the missing angles and the sides. Okay, we try to find them all. So side C, angle C would probably be the easiest to find because we know the angles of a triangle add up to 180. So angle C would equal 180 minus angle A plus angle B. I could put angle B plus angle A. We get it. Okay. Obviously, we need this little bad boy. Domain here. No, we don't need that. Clear that all out. Okay. So where can I put this so you can see it? Right there. Looks pretty good. So we got 180 minus parentheses 81.8 plus 32. So we know angle C now is 67.2 degrees. So this is on degrees. Let me check my calculator here because we're going to be working with it. It's set to radians. So we want to slide over and make sure you reset your calculator to degrees and then hit equal. So, be careful about that. Make sure it's in the right unit. Very easy to make that mistake. So how are we going to solve it? Well, we know A and angle A, small a, angle A. So we could say A is the sine A, or simply 42.9 is to sine of 32 degrees. We're going to substitute in A to sine A. And let's go hunting for B. I don't know, we could assign for anything. So B is to the sine of 81.8. 81.8. So how could we do that? Okay, well, we're just going to multiply the two numbers that are across and divide by the one that's left. So B is simply 42.9 times the sine of 81.8 divided by the sine of 32. So all we got to do is put this into our calculator. Very easy. Put it over here so we can see a little bit better. I've got 42.9 times sine 81.8, but we do want to make sure we close this parentheses. Divide by the sine of 32. I like to write this down because this shows I know what I'm doing. And hit equal, and I get 80.12. So I'm just going to, they said they seem to round it off to just one decimal point. So B is 80.1 centimeters. So now I know this measurement right here, 80.1 centimeters. Now, we already figured out angle C. That was pretty easy. We just subtracted from 100 and 80 out of the two angles we knew. So now all we got to do is find side C. So I usually go with the two given. It's not the one I just solved for because I might have made a mistake. So I'm going to draw a line here. 42.9 is to the sine of 32 degrees as we're looking for C. We don't know C. Side C is to the sine of angle C, sine 67.2. And again, C is equal to cross multiply 42.9 divided by sine of 67.2, and then divide by what's left, sine 32. So you could see, pretty easy to do. It's just a matter of putting it into the formula for a change. Kind of a fun thing to do. I have in my calculator, I've got the 42.9. All I've got to do is change this angle right here to 67.2. I've got my parentheses, and I'm dividing by sine of 32. So all this was basically in my calculator. I'm just going to hit equal. And now I got Side C is 74.6 centimeters. And I'm not going to round up because it's 3 behind the 6. So 74.6 centimeters. And now I know all the angles and I know all the sides, and it's not even a right triangle, huh? So pretty exciting that we could find these missing things, and not a whole lot of work. Basically a proportion type thing. Let's box in these answers so we can find it. Okay, kind of a fun one to do. So let's try another one here. It says there's a river. The Gasconade River is kind of flowing this way. And it says see figure 3, and we want to figure this out. So looking at figure 3, they have a drawing that kind of looks like this. This is B. This is C. I guess they went right to the edge of the river. And there was an angle A up here. Okay, and they want us to figure out, let's see, what else do we know? We know angle C is 112.9, 90 degrees. We know that angle A is 31.1. And we're trying to find angle B here. We don't know that one. We're also looking for, we know this side, which is opposite B, is 347.6, and this is feet. And that's what we pretty much know, huh? So I like to find the angle first because I feel that's the easiest, and we sometimes might need that angle. So angle B is equal to 180 minus parentheses 112.9 plus 31.1. So let's see what that is. 180 plus minus parentheses 112.9 plus 31.1 parentheses equals. I come out with exactly 36, which is kind of weird, huh? So angle B is 36. Let's put that in our drawing. Now we've calculated that. Circle it. Okay. Now, it was important we found angle B because we've got side B and we can compare it. We don't have these other sides. This is side C. This is side A. Okay. We didn't have those other measurements. Usually, even though this isn't a right triangle, we usually let C equal the biggest angle, but not necessarily. I mean, you could have a different. So we're going to say B, here's our formulas. B is the sine B. As let's go hunting for A. A is the sine A. And that's the formula we're going to use. So B, 347.6, is to the sine of 36, as A is to the sine of 31.1. So again, all we got to do is cross multiply. A equals 347.6 times sine 31.1 divided by sine 36. Almost didn't have enough room there. Okay. Or you could just put it over sine 36 like that. Okay. So what is A? A is going to be, let's find out. 347.6 times sine 31.1 parentheses, got it, divided by sine 36. And again, make sure your calculator is set to degrees, which we know it is. And we got 305. And I'm going to round this. So let's see, did I carry it out 2 places or just round it to 1? I'm going to round it up. So I'm going to move this up to 0.5. 305.5. This only went out one decimal point. So 305.5. That would be, what is A? A is the distance from here to here across this lake. Okay. If we wanted to find C, let's go ahead and find C. They didn't ask for it, but would be nice. Actually, all they asked was for A, but we had to find angle B in order to get that. Now, if we want to find side C, we could just say C is to sine of 112.9 as B, which we know is 347.6, is the sine of angle B, 36. So here's a situation where C is over here. So C is going to equal 347.6 times sine of 112.9 divided by, multiplying those two, divided by the number that's left, sine 36. C is, and then we just plug them in. It's not as easy to find the missing, it's easier to find the missing angle than the missing side. Sine, little time consuming, 112.9. Finish the parentheses, divide by sine 36. If you forget this one, it's okay, but get in the habit. 544.8. And of course, we didn't write down the unit, feet. They didn't ask for C, I just did it on my own. This is again C. So pretty cool, huh? All right, this next one is kind of uses the words bearing and stuff like that. So want to get used to seeing a problem like this. It says 2 ranger stations are on an east-west line. This would be east. This would be west. East-west line. A forest fire is located on a bearing north 42 degrees east from Western Station A. This would be Western Station. It's on the Western Station. The bearing is north. So we're going straight up. If it was south, we would be going down. It's north, 42 degrees east. So we're going towards the east, this way, 42 degrees. So we have some kind of a line here, like that. Okay, 110 miles apart. Is Station B. B sees this fire. It's at a bearing north, 15 degrees east. It's also, if it said west, we would go this way, but it's 15 degrees east. So maybe I should have made this a little smaller. Let me erase this. Because we wanted to meet someday. This one's going to be kind of tight. So we'll make it kind of steep. Right here is the fire. Okay, this would be C. And this right here is 15 degrees. Okay, but that's not angle B. Angle B is this whole angle right here. So from here to here would be 15 plus 90. This is a 90 degrees. So the angle B is 105 degrees. So we know angle B. This right here is 90 degrees. Let's see. This is 90. These two angles right here have to form a 90 degree angle. So 90 degrees minus 42 degrees is 48 degrees. So this is angle A. We're looking inside the triangle. So angle B is 105. This is 48. And we know little c right here is 110 because it's opposite angle C. This would be A. This would be B. Okay, so let's figure out angle C right away. 180 minus 48 plus 105. 180 minus, let's see, 5 and 8 is 13, 153. What is that, 27? Let's double check it and make sure. Sometimes my math isn't as accurate as I want it to be. Plus 105. 27 degrees, yeah. I'm going to label this so I know. So angle C is now 27 degrees. We know that. All right, so we're trying to find, what are we trying to find here? We want to try to find how far is the fire from the western station? That would be station A. So we want this distance. This is your western station. So we want to know the distance this fire is from A in terms of miles so that they can sight in on it. So the sine, we could do C over C. This is going to be our formula. Small c over sine of C equals small b over sine of B. So we kind of want to have a starting point here. So small c is 110 over the sine of 27 equals small b, or side b, over the sine of B. This is B. B is 105. Okay, so B is going to equal, side B is going to equal 110 sine 105 divided by sine 27. Kind of cool, huh? So now we can calculate this out. And I think this is a little bit more fun where you're actually solving problems, instead of some of the abstract things we did. We could probably put it that way. I want to put a time sign in there. Sine 105, parentheses, divide sine 27, parentheses, equals 234 miles roughly. You got good eyes if you saw it, huh? You're probably using some device, and I didn't get the right answer. What happened here? Where did I go wrong? Did I goof up? Oh, I labeled these wrong, huh? No, I'm looking at the wrong problem. Well, they said 230 miles. How'd they get that? Let's check my math. 110 sine 105 divided by sine 27. Did I goof up on this one? No, that's what they had. I got 234. Let's check it one more time. 110 sine 105. I got the parentheses. Sine 27 equals. I got it. So I don't know where they came up with the 230. It says use a calculator and give two significant digits. Well, Let's just keep it 234. I don't want them dropping slurry on the wrong place. Okay, I got one last one I'm going to show you, which is kind of an interesting problem. We can find, you're used to the area. What is the area of a triangle? Area of the triangle. If you have a triangle, you want to find the area inside. It's what base times height divided by 2, or 1/2 the base times the height. But we're going to use a little variation on that. On the next page in your book, you can find the area by using, if we have a triangle like this, and maybe we could, here's your base. Let's see, this is angle A, this is angle B, this is angle C, side B, side A, side C. Okay, maybe you have this triangle, and of course this distance right here would be the height. But they use a little variation. The area is equal to 1/2 BC sine of A. Now notice what they did. This is BC, and then you have angle A. A stands for area, not the angle. The area could also be, because maybe we don't know these two things, it could be AC sine what? Missing number B. I bet that would work. See? Or the area could be 1/2. Let's see, we use BC, AC, AB, sine C. So any of those will work. So you have two sides, and then you have a side that's, well, let's see how it has 308s. This side, this is the angle in between, huh? If I use A and C, this is the angle between them. If I use B and C, the angle between them is side A. So we're using the two sides and the angle between the two sides. Pretty cool. So let's see if we want to do one of these things. It says, here's one. I'm going to try to speed this up a little bit. It says B was 55 degrees, 10 minutes. Well, let's go ahead and use it. And A is 34 feet. Little A, 34 feet. And C is 42 feet. So if we looked at our little drawing here, we can see that here's A, is that 34? Can't even read my writing. 34, 42, and what we're trying, we know this angle is 55 degrees, 10 minutes, see? So we're going to use the law of sines. Now, if you don't want to use divide 1/2, you can just put this over 2, like that. So I'm going to use that variation. I'm going to use, let's see, which one am I going to use? AC sine B. I'm going to use this one. So it's going to be A times C times the sine of 55 degrees, 10 minutes, divided by 2. And this should give me the area of that triangle without knowing the height. So let's put it in our calculator. 34 times 42 times the sine of, now I'm going to use my angles, my things here. What was it, 55 degrees? 55 degrees, and I'm going to use 10 minutes, 10. I'm going to go to this key, slide over, minutes, parentheses. And then I'm going to, because this is all times, I'm going to divide that whole mess by 2. Or I could multiply it by 0.5. So the area of this triangle is 586. And I guess I could go 0.06. looking at the wrong problem, excuse me. 586 feet squared. I was looking at this second example. So, but that's kind of the idea behind it. On this next one, I'm not going to do it, but they have to find side B in order to do it because we know they have to kind of use the law of signs a little bit to calculate the missing. We could either find A or C, but they have to use kind of the law of signs to calculate it. And that's what they're doing up here. They were finding side A, and then they were trying to find the area by using the angle between those two, between A and B is angle C. So they went ahead and used that, this one right here, 1/2 AB. So what they were doing on this one right here is you can kind of see that they were trying to find, they had to use the law of signs to find A. And then once they found A, then they could use this formula right here to find the new angle C, and they could calculate it out. So sometimes you might have to go through a two-step approach. All right, I want to keep it too long. So, try some of these problems. You're going to have some problems where you have to do the law of signs, and then you're going to have somewhere you're going to have to find the areas of triangles. So, kind of an interesting little section.